The Earth's oceans are vast, stretching across the globe in an endless expanse of blue, and deep, plunging to depths that remain largely unexplored. They cover more than 70% of our planet's surface, making them a dominant feature of the Earth. These waters play a crucial role in regulating our climate, acting as a massive heat sink and a dynamic conveyor belt that distributes warmth around the globe. They act like a giant sponge, absorbing carbon dioxide from the atmosphere. This process, known as carbon sequestration, is vital for maintaining the delicate balance of our climate system. This process helps to keep our planet habitable by reducing the amount of carbon dioxide, a major greenhouse gas, in the atmosphere. Without the oceans, the Earth would be much hotter and less hospitable to life. The marine ecosystems, from the smallest plankton to the largest whales, all play a part in this critical process. Carbon dioxide is a greenhouse gas, which means it traps heat from the sun in our atmosphere. This trapped heat leads to a warming effect, which can have severe consequences for our climate and weather patterns. Too much carbon dioxide in the atmosphere leads to global warming, causing ice caps to melt, sea levels to rise, and extreme weather events to become more frequent and severe. The oceans help to regulate the amount of carbon dioxide in the atmosphere by absorbing it and storing it in various forms, such as dissolved gas and organic matter. This natural process keeps the Earth's temperature in a range that supports life, ensuring that our planet remains a vibrant and thriving home for countless species. Carbon dioxide is constantly moving between the atmosphere, oceans, and land. This natural process is called the carbon cycle. Plants on land absorb carbon dioxide during photosynthesis. They use it to grow. Animals breathe in oxygen and release carbon dioxide. Volcanoes also release carbon dioxide into the atmosphere. The oceans play a crucial role in this cycle. They absorb carbon dioxide from the atmosphere. This carbon dioxide is then used by marine plants for photosynthesis. It is also incorporated into the shells and skeletons of marine organisms. Human activities are releasing large amounts of carbon dioxide into the atmosphere. This is primarily due to the burning of fossil fuels such as coal, oil, and natural gas. These activities are essential for powering our homes, industries, and vehicles, but they come at a significant environmental cost. This disrupts the natural balance of the carbon cycle. The carbon cycle is a delicate system where carbon dioxide is absorbed by plants and oceans, and then released back into the atmosphere through natural processes. However, human activities are tipping the scales, causing an excess of carbon dioxide that the natural world cannot keep up with. Burning fossil fuels like coal, oil, and gas is a major source of carbon dioxide emissions. These fuels are burned to generate electricity, heat our homes, and power our vehicles. The process releases large amounts of carbon dioxide which accumulates in the atmosphere and traps heat, leading to global warming. Deforestation also contributes to the problem. Trees absorb carbon dioxide and store it as carbon in their trunks, branches, and leaves. When they are cut down, this carbon dioxide is released back into the atmosphere, further exacerbating the greenhouse effect. When they are cut down, this carbon dioxide is released back into the atmosphere. This not only reduces the number of trees available to absorb carbon dioxide, but also adds to the overall carbon dioxide levels, making the situation even worse. The increased levels of carbon dioxide in the atmosphere are causing the Earth to warm at an alarming rate. This phenomenon, known as global warming, is leading to the melting of glaciers and polar ice caps, which in turn contributes to rising sea levels. This is leading to a range of impacts including rising sea levels, more extreme weather events, and increased coastal erosion. Communities around the world are experiencing more frequent and severe storms, hurricanes, and flooding, which pose significant risks to human life and infrastructure, and changes in plant and animal life. Many species are struggling to adapt to the rapidly changing conditions. Coral reefs are bleaching, wildlife is migrating to new areas, and plants are struggling to survive in increasingly harsh conditions. The impacts of climate change are far-reaching and affect every aspect of our planet's ecosystems. The oceans are absorbing about a quarter of the excess carbon dioxide that humans are releasing into the atmosphere. This is helping to slow down the rate of global warming. However, it is also having a significant impact on the oceans themselves. When carbon dioxide dissolves in seawater, it forms carbonic acid. This process is called ocean acidification. The acidity of the ocean has increased by about 30% since the beginning of the Industrial Revolution. This is happening at a rate faster than any time in the last 50 million years. Ocean acidification is having a range of negative impacts on marine life. This phenomenon occurs when the ocean absorbs carbon dioxide from the atmosphere, leading to a decrease in pH levels. As the ocean becomes more acidic, it creates a hostile environment for many marine organisms. It makes it harder for marine organisms like corals, oysters, and some types of plankton to build their shells and skeletons. These structures are made of calcium carbonate, which dissolves more easily in acidic conditions. When these organisms struggle to maintain their shells, it can lead to weaker structures and increased mortality rates. This is particularly concerning for plankton, which form the base of the marine food web. These organisms are essential to the health of marine ecosystems. Coral reefs, for example, are often referred to as the rainforests of the sea because of their incredible biodiversity. They provide food and habitat for many other species. Fish, crustaceans, and even marine mammals rely on these habitats for survival. The loss of coral reefs would have a cascading effect on the entire ecosystem. Ocean acidification can also affect the growth and reproduction of fish and other marine life. Studies have shown that more acidic waters can impair the development of fish larvae, leading to lower survival rates. It can disrupt their senses, making it harder for them to find food and avoid predators. This sensory impairment can lead to increased predation and reduced populations of certain fish species. The impacts of ocean acidification are already being felt in oceans around the world. Coral bleaching events, where corals expel the algae living in their tissues, are becoming more frequent and severe. They are expected to become more severe in the future. Scientists predict that if current trends continue, we could see significant declines in marine biodiversity, which would have profound implications for the health of our oceans and the planet as a whole. Addressing the issue of ocean acidification requires a two-pronged approach: mitigation and adaptation. Mitigation involves reducing carbon dioxide emissions at their source. This can be achieved by transitioning to cleaner sources of energy, improving energy efficiency, and reducing deforestation. Adaptation involves developing strategies to cope with the impacts of ocean acidification that are already happening, and those that are projected to occur in the future. This includes researching and developing more resilient species of marine organisms, restoring damaged ecosystems, and implementing sustainable fishing practices. Natural carbon sinks like mangroves, seagrasses, and salt marshes play a vital role in mitigating climate change. These ecosystems absorb and store vast amounts of carbon dioxide from the atmosphere. They trap it in their leaves, roots, and the sediment below. Protecting and restoring these ecosystems is crucial for enhancing carbon sequestration. It can help mitigate the impacts of climate change. Sustainable management practices such as reducing pollution and preventing habitat destruction are essential for preserving the health and effectiveness of these natural carbon sinks. The ocean plays a vital role in regulating our climate and supporting life on Earth. However, human activities are putting immense pressure on this delicate ecosystem. Ocean acidification is a serious threat to marine life and the health of our planet. We must act now to reduce our carbon emissions and protect our oceans. By transitioning to a low-carbon economy, investing in renewable energy, and supporting sustainable practices, we can create a healthier future for ourselves and generations to come. The time for action is now. Our planet depends on it.